This is Phil M, Mech 140, Midterm. For Objective 1, we're using a potentiometer to control the speed of the motor. The motor will only cut on if the temperature is above 75 degrees. This is determined by using a temperature sensor. Because I keep it cool in the house, I've actually set mine to be under 75 degrees for it to turn on. When I code it over 75 degrees, the motor does not turn on, which proves that my code works. If we take a look at the code, the first section is where we declare all of our different values. We're going to have the potentiometer value, and then we're going to have the different sensors and output, which would be the motor. Next, we have the setup. We're going to initialize the serial monitor so that we can output text to it, and we're going to say that the pin motor is an output. Next, we have our loop. Here is where the first part is where we float a few different values and we do all of our math. We read the inputs and outputs, and then this is the part of our program where we say, if the degrees Fahrenheit is less than 75, output this information to the serial monitor and turn the motor on. Otherwise, turn the motor off and output this information to the serial monitor. For Objective 2, we hooked the LCD screen up to the breadboard, built a circuit to display Hello World. I also have my name on here and a timer that counts up. The code's very simple. The first thing to do is to include the liquid crystal H library. Then we set up all the pins that are used for the liquid crystal display. The setup says where on the display to print Hello World, and then the loop also says what to print next and then where to print the timer. The millis is the timer. For Objective 3, using the same circuit as the previous objective, we now added a temperature sensor, and we programmed it to display the temperature in Fahrenheit on the display. The code for this part is very simple. We're going to set up our variables at the top, which libraries to include, which pins to use. Then we're going to have the setup, which is going to say where on the display to print temperature. And then in the loop, we're going to do all of the math we need to do. It's going to read the sensor, get the ambient temperature in the room, and then it's going to output it to the screen in Fahrenheit. The next objective, we're using a shield that I soldered that plugs into the Arduino, which easily interfaces with VEX motors, push buttons, and the potentiometer we're using here. This shield also allows us to attach the VEX battery to it instead of using a 9-volt. When one button is pressed, the motor will turn clockwise. When the other button is pressed, the motor will turn counterclockwise. When both buttons are pressed, the motor will stop, or if neither buttons are pressed, the motor will also stop. The potentiometer controls the speed of the motor. So once it's set and the button is pressed, it will move at a certain speed. And then if it's turned again and the other button is pressed, it'll move at a different speed in the other direction. In this code, first thing we do is include the servo.h library. We set the servo to DC motor as the variable. We set up our inputs. And then under the setup, we say what our outputs are actually going to be, the DC motor. Also, the other two inputs we have are the two push buttons. Next, we're going to read values of the push button, which one's being pressed. One's going to be clockwise, one's going to be counterclockwise. We also read the value for the potentiometer, and we set two new potentiometer speeds, a clockwise speed and a counterclockwise speed, and we map the proper values to it. Then we have the if else statements, and this is where we say, depending on which button is pressed, which speed to write out, and which direction the motor is going to be spinning, or whether or not we're going to have the motor stopped.